Now guys, today I'm going to introduce to you, maybe new to some, new mathematical objects called the matrices. But I'm very sure if you take your book, the book which you are using, and you open the chapter called matrices, you will see that suddenly you wake up in the morning, there's an animal called matrice, and it miraculously becomes some animal that's described in the book there. But to me that is not interesting. So I would like to try to find, just to introduce a story to you here, a kind of a story. What is the story? The story is, there's a guy called father. Normally this is the guy who sponsors the education, traditional. That's the guy who is supposed to sponsor the education of kids or whatever, something like that. So suddenly this father has got two kids. He's got two kids. But he realizes that on average, for a certain type of necessity at school, let's say type X, he's going to spend a certain price for, let's say for stationery, he's going to spend a certain amount, and maybe for another type of necessity of school, he's going to spend one. This could be pencils, and this could be books, or price of pencils, or price of books. But at this moment, I just chose two types of things. Let's say pencils and books altogether. Then it says, okay, I've got my child number one. It's called child number one. He realized that he has got to buy two of these. He's going to buy two of these. And then three, and then three of these. Whatever these are, whether it's textbooks or whatever, he's going to buy two of these. And then that is for child number one. And the child number two, you realize that, okay, for child number two, I've got to buy one of this. And two of this. Now he has got to work out his expenditure. He says, okay, if for an object number one, or at whatever type of number one X, I've got to buy two of those, and this is the average cost, which means I'm going to give 2 times X, which I write as 2X, plus for this child he's going to buy 3 of these. He's going to say 3 times Y, and he realized that that costs him 7, could be 7 rands or 7 cents. It's not really interesting there, but we know that it costs him a certain amount, 7 altogether. Then on the other side, when you come to this child, the child number 2, so for this type I'm going to buy 1, which means 1x, which I just write as x. And then for this type of object, this could be that, let's say 2, I'm going to put 2 of these ones, 2y, and they realize that for that child he has spent what? 5. Altogether. Okay. Then there is a situation, you will know what is going to spend, blah blah blah, that's fine. But where is the mathematics there? Where is the matrix? Why I'm doing this thing this way? I want you to feel that this thing I'm going to call matrix is not a miracle. Like I'm telling you, most of the books, even the books I used myself to go to school, they give me matrices as a miraculous thing which comes out. This thing looks like this, call it a matrix. But more or less I want to give you a feel of a reality where it can come from. And that's warning. Don't then think that all matrices are come from things like this. In mathematics, one object in mathematics can be used in different ways to describe different situations. So this is not the only way matrices can come about altogether. But I want to give you a feel of something which is actually at the level of development, something which you can relate to, something so that you can see how mathematics comes up in the activities of what human beings. So this guy says, okay man, let me just focus on the totals. If you just focus on totals, he's focusing on this. He's focusing on 7, and 5. That's what it's going to print. Then it says, let me give this the name and say totals. Or you can say, okay, let me focus on the prices, the average prices of the things I'm buying, the 2 types of things I'm buying. Let me focus on the prices. Then you can say, let me call this X, and then there we'll be talking about X and the Y. Then the other thing is left now are the quantities. Do you see the quantities? Do you see the quantities? So the quantities is got there. Let's say, let me call this A, and the quantities actually for type 1, the quantities for type 1 article, I've got 2 and 1. So it comes in, right, 2 and the 1. And then for the other type of quantity, right here, 3 and the 2, then it's got that. Then it's realized this is interesting. It's got something very interesting there. What you've got here, T, X, and the A are matrices. Those are what you call matrices. That is such kind of an animal. What is that animal for there? It's representing certain information. The person who has put it like that, he understands exactly that these are the quantities I'm going to buy for this type, this quantity, this type, this quantity. It's for representing information. When you wrote 1, what do? You're representing a quantity of a certain type in a certain set or whatever, or quantity of people in a certain house. When you write 2, you are maybe representing a quantity of parents, 2 parents, my father and mother, that's 2 altogether. So this is another way of representing information. And in this case, this type of setup, these things individuals are called matrix. Now it's X is a matrix. X and A are matrices, so this is plural. And as you can see, these things are of different types. This has got 1, 2 rows. This has got 1, 2 rows. This has got 1, 2 rows. But when we go this way, this has got 1 column. This has got 1 column. In other words, now we can say T and X are column matrices. What are we talking about there? We are talking about the type of the matrices altogether. That one matrix, this matrix is column matrix, but just 1 column. Now, how are we going to call this one? A. A is actually a square. A square. Sorry, there's an A missing there. Square matrix altogether. So now, how are we just going to say matrices are square and column? No. What we're interested in when we talk about the type matrix, why type, let's say type of a matrix. Type of a matrix. We're interested in number of rows, and we're also interested in number of columns. So we're also always going to say a matrix is of type R by C. So what type A is? 2 by X, 2 by 1 altogether. Okay, so guys, welcome to the new world. The world which has got mathematical objects called matrices, and they are of different types, and their types are given by row by column. Notice, if you don't want to forget this thing, tomorrow don't say column by row. If you don't want to forget this thing, what is the landmark there? Not to forget, these letters don't come alphabetically. So just remember, you have got to deal with columns and rows. But when you give the type, you don't give it alphabetically. Row by column. Any questions at that point? All what I've done here is just to give you an animal. I to make sure that you see how the animal looks like, how the same animals can be of different types, and then the next big question will be, what can we do with these animals in mathematics? That is what is interesting now. Do you understand what I'm saying? That now we know, if I throw something on the board there, you must be able to say, that is a matrix. It is of the type. It has so many columns. It has so many rows. So the type is row by column this way. Can you all do that? Okay, right. If you can do that, let's do it. Let's see. Let me say the matrices. Right. I'll just start by the convention. Matrices, their names, as we have seen before, we use capital letters to name matrices. So that is the convention which you must hold on there. Let's say I've got matrix A. Matrix A is minus 1, 2, and 3. Then this one is 1, 3, 4. Then it's 5, 0, 1. Are we together? Now, before I go further there, what type of matrix is this one? 3 by 3. 3 rows, 3 columns, isn't it? Now let's come to B. Right. What type of matrix is that? 3 by 2. Then and this one 3 by 3. Let's get the last one now. This is 6. All together. That one is a square matrix 2 by 2. Good. Let me highlight some important things about matrices now. Look at how I wrote 12 there. I wrote it intentionally. I put 1 and 2 very close to each other in the space 3. 12 as a number there, or 1 as a number here, 4 as a number there, 0 as a number there. Those are called entries of the matrix. Those are entries of the matrix. I think some people sometimes say the elements of the matrix, but I prefer to say those are the entries of the matrix. Individual, they are entries. Let's look at minus 1 in A. Minus 1 in A. Minus 1 in A is an entry. But notice that it is at a special position. That minus 1 is the entry A11. These entries, I use small letters there. I call it entry 11. What do I mean by that? I'm saying this entry is in column 1 and in row 1. Guys, I hope you can see that we're creating a language here, which we must share. When I'm talking about an entry 11, everybody must be comfortable what I'm talking about. All together. Row 1, column 1. Let's talk about 2 in A. Matrix A. 2. 2 there is 1. 2. Row 1, column number 2. All together. Finally, what is A33? I'm asking you. 1. So I hope everybody now understands my language there. Our language. Are we together? Are we there? Okay. Okay, I see there are questions. Now, can we continue? I think we clarify that always when we're talking about a matrix like this, let's clarify that. We start with the row. This is in row 1, column number 2. Are we together? So maybe preferable we could have taken this way and that way. To start with row and column. Standard. All together. Okay. So that is fine. Now let's highlight something there. Your book, like I said, your book says when it comes up into matrices, it says a matrix is a rectangular arrangement of numbers. So, voila, in the morning there's a rectangular arrangement of numbers, use a matrix. This is not how it depends. So now, matrix, of course, this comes up to be rectangular. This is rectangular. That's what we see when we look at it. We've learned what a matrix is. That the shape is rectangular generally. It can be square or rectangular. Now, when we're talking about that red line there, that you call the principal diagonal of the matrix. Principal diagonal. Principal I made a mistake there and erased part of my matrix there. What was the number there? 3. Okay. This one, let's call it principal diagonal. I think somebody will now guess what is the secondary diagonal. The secondary diagonal. Who can guess it? Tell me the entries on the secondary diagonal. The entries. What are the entries on the secondary diagonal? Tell me from the bottom up. 533, isn't it? So that will be the second diagonal. Secondary is what sometimes we call secondary. Né? But because some people emphasize that we must say secondary, we always try to say secondary. But in my culture, it's secondary. Okay, that's right. Okay. So, but this one, like this, it is no, like, was not square, the diagonal is not very clear. Okay, so that's that. Now, I said the question was, once we've known what it could be, or first of all, before I get to there, what you can do with matrices, let's talk about this one, this matrix. I'm picking up special matrices now. This is what you can call a zero matrix. A zero matrix. It will behave exactly like a zero. If you know zero. Did you know zero somewhere? 0 and 1, 2, 3, 4. 0, 1, 2, 3, 4. So this matrix will almost behave like zero. We see how it behaves like zero. Then we also have got a matrix like this one. The interesting thing about this matrix, which you must focus on, that it has got zeros everywhere, and the ones along the use the language along the principal diagonal. That is called an identity, not identity function, but an identity matrix of order 3 by 3. So I can write it here I 3 by 3, meaning it's an identity of order 3 by 3. Then try to imagine what is an identity of order 100. What is an identity of order 2? Altogether. Okay. So that's an identity. Otherwise, besides being an identity, a matrix which has got entries, zeros everywhere, except on the diagonal. We'll also call it a diagonal matrix. So this identity matrix is actually also a diagonal matrix. Diagonal matrix. I'll just write the diagonal mat, meaning it has got non-zero elements or entries only along the diagonal. Now, big question now is, what can we do with these animals? What can we do with matrices? I think we should wish that if this is mathematics or part of mathematics, we should be able to do all the things we're able to do with numbers. Isn't it? Multiply, add, divide, whatever. But let's see what can we do. All together. Okay, let's clean our board a bit. Now, first question is, can we do something like this, a plus b? So let's say b is here is 4 minus 1, 3, 4, 12, 3. I think everybody wonders how, if we can add here, how are we going to add? What's going to be our choice? What do we do? Because if we add a number and a number will get another number. If we add a matrix and a matrix, we should get another matrix. But obvious, if you get a donkey and a horse, you will not get a horse. So this is impossible. All together. What am I saying? The message is, add matrices of the same, tell me, complete the sentence, of the same type, underline type, add matrices of the same type. So now, I can now have 2, 3, 4, 5, 2 by 2, plus 0, 1, minus 3, 6. So I've got matrices of same type 2 by 2. Then I should get a new matrix which I can get here by adding these two. Let me tell you what you do. You add corresponding matrices. In other words, A11 will be added to B11. So if this is matrix A and this is B, A11 must be added to B11. In other words, you must match. All together. If you don't know how to match, take your hands, 2 hands, put them in front of you, this way, facing each other. A thumb to a thumb, pointing finger to pointing finger, until little finger points. That is matching. So that is how you do addition of matrices. All together, guys. So what am I saying there? I'm saying we're going to write 2 plus 0. Then write 3 plus 1. Then write 4 plus minus 3. Then 5 plus 6. Then after that, the rules of signs, of combination of signs, must be respected like before. Then you say equals. That will be 2, that will be 4, that will be 1, and that will be 11. And please notice how I write my 11. I make sure that the numbers are together in such a way that they show that they're in one column with 4. All together, guys. That's very important. So, if we can add matrices of the same type, I think it's almost natural that you can subtract matrices of the same type, isn't it? So, addition and the subtraction goes together for the same type of matrices. So, let me say that add or subtract matrices of the same type. Then if I give you two matrices, I just give you instruction add, and the matrices are not the same type, your answer is just to write there, not applicable or impossible. Are we together? I'll be just trying to test whether do you know when to add matrices. But somebody who doesn't know will do anything, because anything to somebody who doesn't know is a miracle. Are we together? Yeah. If you don't know, anything is a surprise, anything is a miracle. That's fine. Okay. Questions, guys. If you have questions, can I turn to questions now? Are there any questions this far? Because I'm really going to move a bit fast now. That we know the animals called matrices, I'm going to move very fast. Are we together? Okay. Right. If there are no questions, then let me stop there and assume that you're going to go to your book. See as many matrices as possible you can add and add them. Just enjoy it. What you call it? Embrace it. Do like a sponge. You know, when a sponge, you put it in a saucer, there's what? There's water. The sponge just embraces all the water. It's needed to see the water at the top of the sponge when the water was only at the bottom. So you start go into the thing, immerse yourself in it until you feel like you are one and one with the water and the sponge. In this case, the water is the addition of matrices. Thank you.